Let's now go to improper integrals. What are improper integrals? They are of the form, diba ang proper na to is, ang limits of integration are supposed to be constant. So for an improper integral this time, the limits of integration would be values such as infinity. No? As long as f is continuous for all values of x greater than or equal to a, then the integral from a to positive infinity of f of x dx is equal to, you take the limit of the integral from a to b of f of x dx, wherein b there approaches positive infinity. As long as this limit exists, then you can have the 12. Okay? So, pag naamo integral, makita nyo na siya limits of integration na positive infinity, then you make use of this. Limit b approaches positive infinity, ang inyong b, ang inyong infinity replaced by a constant b there. But you let b approach positive infinity. Pwede po siya nga naadri sa ubos ang iyang infinity. And when that happen, then you will have like this. So, if f is continuous for all x less than or equal to b, then the integral from negative infinity of b of f of x dx is equal to the limit of, you replace your negative infinity by a, as a approaches negative infinity, replace it by a, of f of x dx. Or, if you have this one, dalawang infinity, positive and then negative, then you take the limit from a to negative infinity, as a approaches negative infinity, your a there, and then put lang ninyo sa 0. Diba kay, ang inyong value, let's see, so 10, namoy 0 diha. Padalang dito is your negative infinity. Padalang dito is your positive infinity. So, you consider kanina adiri from negative a approaches negative infinity, so you have a to 0, and then from 0 to b, where b approaches positive infinity. Okay, as long as those limits exist. Note that if the limit exists, we say that the improper integral is convergent. Otherwise, kung di naman exist ang iyang limit, then we say that the improper integral is divergent. So let's take the first example here. Evaluate the integral of dx over 4 minus x squared from negative infinity to, and consider if actually it converges. So how do we know that it is convergent? If the limit exists. So we take now this one, we rewrite this as naman sa ubos. So a approaches negative infinity. So a to 2. So when a approaches negative infinity, you will have, you integrate first what is your integral of dx over 4 minus x squared. Diba kani siya, kay ma-rewrite na siya as 4 minus x to the negative 2. Correct? So 4 minus x to the negative 2, then you should have what? Negative dx dapat ang inyong derivative. Correct? So negative dx dapat dito. Pero wala man tayo negative, so you have to consider the negative value. Okay, let's see. Ito na lang. So when you take the limit of a to 2, there, a approaches negative infinity, then we have dx over 4 minus x squared, the quantity x squared. Diba dapat na-rewrite man siya as, if your u is equal to 4 minus x, then your du is equal to negative dx. Rewrite niya siya as a to 2 of 4 minus x to the negative 2 dx. Limit a approaches negative infinity. Pero kani ang kinahanglan nato kay negative. Ang diyo dapat kay negative dx. But you only have dx there. So if you have, you need your negative. So that should become limit now of the negative of a integral from a to 2 of 4 minus x to the negative 2 dx. A approaches negative infinity. But then, when you integrate this, diba, mahimo siyang negative 2 plus 1. Diba, u to the negative 2 plus 1. So, mahimo na siyang negative 1. But, kung sa manang negative 1, 1 over 4 minus x to the negative 1, which is this. So, you now have 1, pero negative siya, the negative po ning inyuhang diha, so you will now have 1. So the result is this. So the limit now of 1 over 4 minus x from a to 2. Okay na ito. So it's now the limit of 1/2, you have, minus, substitute f of 2, which is, you will have this equal to the limit of, okay, a approaches negative infinity, 1 over your a there, from 2 to a. So 4 minus 2. 4 minus 2 minus, okay, 1 over, substitute, 4 minus a. So 4 minus a. So 1/2 minus 1 over 4 minus a approaches negative infinity. But this is 1/2, this is a constant. So the limit of this is simply 1/2. And the limit of this one, that's 1 over 4 minus a, this one turns to negative infinity. So this one would become a very large value. So this will turn out to be 0. So I have a 0 here. So the answer is 1/2. Therefore, you have there convergent because you have a value. It converges to 1/2. On the other hand, if you have negative infinity to positive infinity x dx, then what do? You consider kaning sa ubos. Consider this. A approaches negative infinity. Ito nga, no? So 0, x dx plus limit kaning sa taas na po, B approaches positive infinity x dx. So you have from 0 to b, from a to 0. And then, again, you try to integrate what is x dx. The integral of x dx is x squared over 2. And so that when you substitute this one, 1/2 x squared over 2, the value from the upper limit is 0. So 0 minus 1/2 of a squared. So you have negative a squared. And this one from b, so upper limit is b. So 1/2 b squared. So minus 0, 1/2 0. So you have 0. And then, if you take the value, yeah, what is the limit of negative 1/2 a squared as a approaches negative infinity? This will turn out to be infinity. Kani siya, infinity gihapon. So, neither of these two limits exist. Therefore, kani nga integral actually is divergent. Okay, the limit does not exist here. On the other hand, kani limit of x dx, negative r to r approaches positive infinity. Then, you have kani negative r. Ang r naman nag-approach sa positive infinity. So, limit now of 1/2 x squared negative r to r. Negative r to r. So, you can rewrite your negative r. Upper limit muna. That's 1/2 r squared minus 1/2 r squared. Substitute na po kaning negative. But when you substitute the negative value and you are to raise it to the second power, positive lang yapang gawas. But this one is simply equal to 0. So mean to say it's 0, therefore it is convergent. So kanina, this one is actually convergent and the value is equal to 0. There are other improper integrals. So if you take a look at this one, ano lang din, you have to, kay negative infinity to positive infinity. So again, ang gagawin, hatiin siya sa gitna. You have from A to 0, then from 0 to B. And that's the time that you, again, kani siya, nagamit na po siya o inverse integral of inverse tego function. So tangent inverse kani. Formula lang yan, no? Formula lang yan, inverse lang yan. So, you have to recall back your formulas. Importante siya kaayo. Then, example 4 for sine x dx, convergent or divergent, you have 0 to positive infinity. So, 0 to positive infinity, ang bilang, ang b approaches positive infinity. 0 naman to dito. So, when b approaches positive infinity, you take again the limit from 0 to b, upper limit na ng b, so negative cosine of b, but b approaches positive infinity. So it says that for any integer n, as b takes on all values from n pi to 2n pi, cosine b takes on all values from negative 1 to 1. So that the limit of cosine b does not actually exist. Therefore, the improper integral, again, kasi b infinity man to. So, it is again divergent. Other improper integrals would be if you have the following: a plus epsilon, then epsilon approaches, epsilon approaches 0 from the right. That is, if you have half open interval, to pag-iwan ani a, then comma b, meaning to say, ang inclusive ani kay ang included kay ang b, pero ang a kay dili siya included. So bale ang value ani should be a little bit greater than a, kay dili man siya included o open interval. So a plus a certain epsilon, ano siya magamit mo, a plus epsilon. If in case dili ang open sa pikas and then close diha, then b minus epsilon, kay before siya makaabot, so wala pa siya nakabot sa B, that's why make use of B minus epsilon. So, that's how you do it. Pero pag dalawa pananglitan, then, within that interval from A to B, then, before siya makaabot, na siya, except when F is continuous for all x in the interval AB, except when A is less than C, less than B, and if the limit of f of x is equal to positive infinity. Then what you're going to do is, kung except siya at C, then magkuha mo value na before sa C, which is C minus epsilon, and then after C, which is C plus delta. So kung naadiri, continuous siya from A to B, continuous siya. Pero naa siya, dili siya continuous ani. So, yung buhaton kay magkuha mo value before sa C, which is, this value is C minus epsilon, and then after sa C, which is C plus delta. So, diha magsugot. Take the limit, delta approaches 0, mean to say, gamay ra kayo ng delta na ni. Lapas lang gamay siya sa C, kanipod is, gamay lang kayo ng inyong epsilon, kulang lang gamay para makaabot sa C. So that's the concept of limit if you remember. So if you have 0 to 2, okay, ito na. If you take a look at this one, di ba dili siya, kano sa man siya dili defined? Pag x is equal to 1. Correct? Are you with me? Hello?
Yes, ma'am.
So, tanawin ninyo, di ba dili siya ma-define at x equal to, ano siya natin? Dili siya ma-define when x equal to 1, correct? Okay, when x equal to 1, you will have 0 sa ubos. Pero, pwede siya bahinon. That is, nagkuha mo from 0, and then sa dili pa siya makaabot sa 1, which is 1 minus epsilon dx, plus limit na pod, after na pod gamay sa 1, that is 1 plus a certain delta. So, kung asa siya ma-undefined, as long as defined siya within undefined siya sa endpoints, di ba? Pero dili siya define sa tunga-tunga when x equal to 1. So, muna nga, inyong bahinon 1 minus epsilon. So, before makaabot sa 1. And then, kung man sa 1, delta, 1 plus delta. Okay? So, kaning delta should approach 0. Say, gamay na nakaayo. Ilapas lang siya gamay. Bali, ani ba? Yung value. So, notes. Kung naadiri ang yung 1, so, before sa makaabot sa 1 is your 1 minus epsilon. Before, ay, dili man siya pwede, dili man siya continuous diha. So, after na dayon, ang sunod niya is 1 plus delta gigamit. Kaya not necessarily nga the same value man. Basta kaning epsilon ninyo, approach lang siya sa 0. Take the limit as epsilon approaches 0. Take the limit as delta approaches 0. Okay? From the right, dapat from the right para positive yung value. So you have this. So minus, then integrate, and then pag abot dire, pag nakuha ng integral, i-substitute na dayon na when delta approaches 0. So what happens? 1 over delta. Undefined man na siya. Kaning 1 over epsilon. Undefined po. Muna nga divergent ang. So divergent siya. Suppose that in evaluating the integral, in example 1, we had failed to note the infinite discontinuity of the integral at 1. We would have obtained negative 2. Diba? Kung wala ninyo nakita na, undefined man siya. Tapos mag-directly substitute mo, which is obviously an incorrect result because the integral ana is never negative. The integral from 0 to 2 could not possibly be a negative number. So, ang solve kay negative 2, masolve man ninyo, pero mali. Kay mali ang solution. Evaluate x ln of x 0 to 1. Okay. If this is the case, what happens? The integrand has discontinuity at the lower limit. Kung wala man tay, you will have x, 0, ln of 0. So that's why, malapas po gamay, dili mo you will have epsilon approaches 0 from the right. So greater than 0 siya balik. So which is greater than 0, then when you have 1/2 x squared ln of x minus 1/4 x squared from epsilon to 1, then you can actually rewrite this as kanina, no? And you can integrate. So pag-integrate mo kung ano, yung result is 0. You have pag-substitute and pag-integrate and substitute and result is 0 minus 1/4 minus 1/2 limit of e squared ln of b. But what is your ln of e? E there approaches 0. Okay. So to evaluate, we now have the following. You can apply your L'Hopital's rule. So ang answer, if you take a look, is actually negative 1/4. And you got that because you apply ang dalawa ka properties. So you apply also your L'Hopital's rule. Because the limit of ln of b is equal to negative infinity, and 1 over is the quantity squared is equal to positive infinity. And if you have your negative infinity over positive infinity, that is supposed to be a quantity wherein you can make use of your L'Hopital's rule. Diba? So infinity over infinity, then you can make use of L'Hopital's rule, which is kwaon ang derivative sa numerator, then take the derivative of your denominator. And you come up with the following value. Example 3 here is this one, square root of x squared minus 1. You remember again yung this is a topic on atong naatay second, pag x squared minus 1, you can replace that with u squared minus 1. Replace that with second theta, no? Tapos pag a squared plus u squared, ma-replace yan with tangent theta. You remember that? And then the other one is integrals by trigonometric substitution na topic. Okay? So ito yan siya. So improper integrals, so infinite limits of integration. So ito yung additional ninyo. Dito tayo po ng additional na problem set. is due. 5 na yung kanina binigay ko, no? So, medyo marami. Another, mga 3 lang siguro ang kunin ko dito. Kunin ko rin. 2. So, 3 dito. Ayan ko muna yung recording. Stop recording.